This is the final project for E63 Big Data Analytics, real-time text processing with NLTK, Natural Language Toolkit for Python. I'll give a quick overview of the project, go through some of the slides, look at the Python code, and then run a demo. So the quick summary is this project connects to Twitter, sets up a stream of tweets, reads them off, pre-processes the data, puts it on a Kafka queue for buffering, and then a consumer is running which reads those off of Kafka buffer, and then uses NLTK to analyze the text and plot out the results. A couple of the packages that are used. Twitter's data source, there's a package called Tweepy. It's a Python interface to Twitter. That's sort of new to the scheme here. And then Kafka and NLTK we're familiar with from earlier in the class. And so this project strings all these things together to perform real-time text analysis. So basically we have two programs running, a producer and a consumer. So on the producer side, it does some pre-processing after it reads the messages off the queue, skips retweets, etc., and puts that stuff on the buffer. And on the consumer side, it's doing two NLTK analysis functions. One is a regex parser, so it looks for a grammatical pattern in the lines of text or within the sentences actually. This is kept very simple here so that we see a good amount of data coming out of that. You can easily create a very sophisticated grammatical structure to look for in the text, but then you're not going to see much coming back, so that's not as much fun for a demo. And then periodically it performs a frequency distribution on batches of messages, more or less, that come off of the Kafka queue. So right now it's set for every 200 Kafka messages, which each message could be a bunch of sentences, could even be several tweets sometimes. It doesn't really break things down to the individual tweet on this end. It's just a lot of text, and performs the frequency distribution, and then that is plotted out in a bar plot which gets updated periodically for every batch. So we'll go over and look at the slides. There's our consumer running, waiting for us to start up the producer in a couple of minutes. So the slides kind of already, there we go, went through some of this, so we'll just skip down here. And this is a few details about the Twitter. So you need a Twitter account to run this, and you need to sign in and create an application, which is just kind of an identifier to link your account to your stream. That's all that is. It's very easy to set up, and you create security tokens and keys for that application that you define, and those token strings are pasted into the producer.py, and then they're used by Tweepy to authenticate with Twitter and set up the stream. But don't shy away from this because of that, because this only took me 5 minutes and I had really never done anything on Twitter before. So I created an account, set up the application, generated the security tokens, etc., and I did all that in 5 minutes or so. It was very easy to do, and all the steps are specified in detail in the full project report. And the reason for that is Twitter wants to know who's connecting and streaming their stuff. So that's reasonable. And it's all free, of course, so no problem there. Some of these details just kind of talked about this stuff, so we'll skip over that. And so now we'll go look at the code, and we will kind of cover some of these details again. Well, first we'll look at a sample output. So this is just a snapshot of the thing running. So over on the left we have the producer printing out every 10 tweets that it receives. It prints out the total tweets. You see some limit messages in here which are coming from Twitter, because when you string together a bunch of search terms to set up a queue on Twitter. They detect that your search terms are generating large amounts of tweets, and so something's being limited there. Also in conjunction with how fast you're reading them off of your Twitter queue. And so they send you these limit messages, and sometimes the numbers keep creeping up. So I have a little check in the program if it gets above 250 to disconnect. If your Twitter queue gets backed up, then they will send you warning messages, start limiting your rate, and or just disconnect you altogether. All the more reason why each person needs their own tokens, etc. So you're managing your individual streams. And here's the regex grammatical pattern searching mechanism in action. Here's some of the output for that. So it prints out the fragment that it found, or the pattern that it found, and the sentence that it came from. So now we'll go over and look at the Python code. Here is the producer. So here's all our search terms up top. Initially I just did sports, but tweets weren't really coming back too fast, so I added movies, politics, food, weather, and that cranked up the volume quite a bit. Here's where you would paste in your security tokens, and then build a regex here, Python regex, to filter these terms out. So you can either set that to true or false. You may want to leave them in so you see how often you're seeing basketball versus baseball versus hockey, etc. In the tweets, you want to compare those different areas, but I have it defaulted to true right now to strip them out of the messages, so that you're looking at the language that people are writing in association with these things, altogether in general. But you can play with that, turn that on and off. And one other point here, so when you put baseball, that should bring back hashtag baseball, but also other messages that just have baseball in the text is how it is defined. Here I inherited the tweepy.stream class and just set up a catch for the Control C. So when you exit your program, you want to shut down the stream gracefully. It may or may not be already taken care of deep in the tweepy code somewhere, but I did it explicitly here. And then the key thing here is the inheriting the stream listener object into another child class and overriding the onData function. This is where all the action is happening. So when tweepy reads a message off of the Twitter queue, it calls this function like a callback function, passes that message to it, and so basically we load it into a JSON object and start processing. So first we look for those limit messages and call the onLimit method if that is the case, and deal with that. Then here we filter out retweets. So there's a retweeted field in the message. And so if it's an official retweet, we filter that out. Also, if it's an ad hoc retweet where people just do RT@ in the text, then we filter those out as well, because we don't want all that duplicate text. It'll skew things. Convert to ASCII2 to get rid of other kinds of symbols and stuff, so that we're just looking at words. We're doing language processing here. And we strip out HTTPS and HTTP because those are occurring pretty often in tweets, because you get a lot of ads sometimes and stuff like that. So we don't want that skewing things. And so here's where we remove the filter terms from that regex up above, and then it gets put on the Kafka queue by calling the producer. And I'll back up real quick. So that producer is in the constructor of the class. So when you initialize this object, it will also initialize the Kafka producer with it. So down here in the main, we're setting up the authentication here by passing those keys to the auth function. So you get an auth object, and you create an instance of the stream class here by passing the auth object to it. Oh, I'm sorry, backing up. So first we get a listener object right up here, and then we create the auth object, and then we create a stream object by using the auth object and the listener object. And so the stream is where the action gets initiated, and so we set languages to EN, so we're getting English language text, and using the the English language stop words in the NLTK, etc. So we limited it to one language. And here we have our list of filter terms that we pass. So track is the keyword here, and we're tracking all those terms that we have listed up top. And then we're going to jump over quick to the producer, and to the consumer, sorry. And so here's that regex that we had looked at before, and it's just wrapped in a function. So when it detects it, it prints that stuff out, the little tree associated with that, and then the sentence that it came from. Down here, more general Kafka consumer stuff. And right here, this is a key little thing. So when Matplotlib opens that plot window and draws the plot, from some of the homeworks you saw, that it'll just sit on that until you exit that window. And so we don't want the script stopping on that. So this little key thing here for interactivity, call that function on the plot, and it allows everything to run in parallel and then dynamically update. So we're tokenizing everything here. The messages into sentences, the sentences into words. So we call the chunk detector here, and then we remove the stop words before we do the frequency distribution, etc. And then we come into here. So every 200 messages coming off the Kafka queue, we perform the frequency distribution, and then plot those results out and clear that sort of local batch list, and let it keep running in a loop. And so now we will come over to the Linux VM. There is our Kafka consumer waiting patiently. Here we have Zookeeper running in the background and Kafka. You might remember that from week 5. And here's the producer. Going to crank that up. And there's a list of terms we're using that's printed straight from the Python script, so nothing really happening yet with Twitter. And it should start up pretty quick, hopefully. There we go, tweets coming in. And we're already getting some limit messages. So it's off and running. And we see some sentence patterns being matched, the little grammar pattern, and our first plot just came up. And there's another plot already, so it's moving pretty quick here. We see quite a few limit messages, so we got a very active queue. And who knows, there's all kinds of variables in loading up that stream on the Twitter side and reading them off. The Python script could maybe be a little more efficient, or just could be all kinds of network stuff or whatever. And here's the sentence fragments coming out, and plot updating again. So we saw this change. Well, some of these things are quite common, and they're hanging around from batch to batch, and some of these other ones down here are getting eliminated, replaced with other stuff. So that's kind of common. Yeah, those things are staying up at the top too, and this other stuff kind of varies a little bit. And you can play with searching on different track items, etc., and look at all kinds of stuff. And so we have a change over here. So now we have hiring and job up at the top. There we go. We're getting some good changes here. And there it is. Real-time text analysis with NLTK and Tweepy.